For over 70 years, the story of artificial intelligence has been this wild roller coaster of incredible hype and then just crushing disappointment. It's this cycle of brilliant summers where it feels like anything is possible, followed by these devastating winters where all the funding dries up and the promises fall flat. Okay, let's dive into this epic journey of booms and busts.
And get this stark warning came way back in 1984 from two of AI's own pioneers, Marvin Minsky and Roger Schenck. They saw the hype bubble building in the 80s, and they knew exactly what was coming next. And they weren't just being dramatic. They'd already lived through this cycle once before. Their term, AI winter, just perfectly captures that deep freeze that would hit the field again and again. So here's what we're going to cover. We'll start with the super optimistic birth of AI, then we'll get into the brutal winters that followed. We'll unpack the two rival philosophies that were basically at war for dominance. We'll try to understand the crazy boom we're in today, and finally, see how a new hybrid approach might just be changing the game for good. All right, let's rewind all the way back to the beginning. Back in the 1950s and 60s, a really powerful idea took hold in this tiny new field called computer science. It was a time of just pure, unbridled optimism. The first AI summer was in full swing. Now, this idea, known as the physical symbol system hypothesis, was basically the bedrock of all early AI. The theory was simple, but kind of profound. If you could just represent the world using symbols, and then give a machine a set of logical rules to shuffle them around, you could literally create intelligence. They figured human thought was just a really, really complex version of that same process. And for a while there, it totally seemed like they were right. I mean, the early successes were stunning. You had the logic theorist program proving dozens of math theorems. The general problem solver could tackle all different kinds of formal problems. And Arthur Samuel's program taught itself to play checkers so well it could beat him. In these clean, structured, logical worlds, AI was already looking like a genius. Yeah, but here's the thing. The real world isn't clean or structured. And when these brilliant toy systems tried to step out of their perfect, logical playgrounds, they just fell apart. All those grand promises made to the funders collided with a much, much messier reality. And the first winter was on its way. And this timeline just lays out the cascade of failures perfectly. It really kicked off in 1966 with this big promise of automatic machine translation, but the systems just weren't even close to good enough. That failure led to these damning government reports, which led to massive funding cuts from DARPA in the US. And even after a brief thaw in the 80s, you saw entire markets and massive government projects just collapse. For decades, AI research was basically stuck in a deep freeze. So what actually went wrong? Well, the key word here is brittle. Early AI had zero common sense. A system that could prove complex theorems was totally stumped by basic ambiguity and just, normal human language. It couldn't handle uncertainty or the nearly infinite list of exceptions that make up our world. The logic was perfect, sure, but reality just isn't logical. This huge failure basically tore the AI world in two. It created these rival camps, a kind of philosophical war that defined the entire field for decades. It was a battle between the neats and the scruffies, a debate over what intelligence even is. So on one side, you had the neats. This is that classic, symbolic approach we've been talking about. They believed intelligence could be built from the top down, with perfect logic, explicit, hand-coded rules, and human-readable symbols. It was a very elegant, structured, and formal vision of the mind. And on the other side, you had the scruffies, or the connectionists. Their approach was, well, a lot messier. It was a bottom-up approach. Inspired by the brain, they believed intelligence wasn't programmed with a bunch of rules, but that it sort of emerged from a whole network of simple, interconnected units, like artificial neurons, that learned patterns directly from data. Okay, I love this slide because it just breaks it down so perfectly. Think of symbolic AI as this incredibly meticulous librarian. Every single piece of knowledge is perfectly cataloged. You can trace its logic from point A to point B. Connectionist AI, that's more like an intuitive detective. It sees patterns and mountains of evidence that nobody else can, but it often can't really explain how it got there. It's a black box. So the trade-offs were just stark. Symbolic systems were transparent, but super brittle. Connectionist systems were flexible learners, but they were totally opaque and needed massive amounts of data, which for the longest time just didn't exist. Neither side really had the whole answer. All right, so how on earth did we break that stalemate and get to where we are today? Well, after another long, cold winter, the pendulum began to swing back hard. And that's what led to the incredible AI summer we are all living through right now. Now, to be fair, there was this little mini summer back in the 80s. It was built on these things called expert systems. These were symbolic AI programs, like one called MySyn that could diagnose blood infections. And they were just packed with hand-coded rules from human experts. They were successful enough to spark a commercial boom and get some major government investment. And when I say major investment, I mean major. The US government's Strategic Computing Initiative poured $1 billion into AI research. The explicit goal was to achieve full machine intelligence. But just like before, the promises way outpaced the reality, and it all eventually led to the second AI winter. So here's the crucial point. Today's boom is fundamentally different. Two things changed everything. First, the explosion of the internet created these absolutely massive data sets. And second, advances in computing gave us the raw horsepower to actually process all of it. These were the exact ingredients the Connectionist scruffies had been missing for decades. Their time had finally come. And wow, just look at this graph. It tells the whole story. This shows the growth of published AI research papers. See that line shooting straight up after the late 90s? It's leaving everything else in the dust. This isn't just a thaw, it's a completely unprecedented heat wave of progress and investment, and it leads directly to the large language models we're all using today. But here's the twist. The story doesn't just end with a victory for the Connectionists. The most exciting frontier in AI today is actually a truce. It's a powerful new combination that's trying to get the best of both of these historical rivals. This is the core question behind Neuro-Symbolic AI. What if you didn't have to choose? What if you could build a system that had the logical precision of that librarian and the intuitive pattern matching skills of the detective?
And this isn't just theory. Researchers are already doing it in really fascinating ways. I mean, take AlphaGo, the program that beat the world's best Go player. At its core, that's a classic symbolic system searching for possible moves, but it uses a powerful neural network to intuitively guess which moves are the best. That's the first approach you see here. Or even look at the language models we use now. They process our words, which are symbols, making them a different kind of hybrid. These old enemies are now becoming powerful partners.
And the goals here are absolutely huge. By adding in symbolic reasoning, we could finally crack open that black box of neural networks and make them more trustworthy. This approach could also help AIs learn from way less data. And, this is a big one, finally tackle the hallucination problem, where models just confidently make stuff up. It's like adding logical guardrails to the incredible creative power of deep learning. Which brings us to our final question. This new hybrid approach really seems to be targeting the core weaknesses that caused all the past AI winters. The brittleness of pure logic and the opacity of pure neural nets. So after this long 70-year roller coaster, is it possible that this AI summer is the one that actually lasts?